Hello, Thomas Jefferson University. My name is Luke Matthew, and I attended the Life Sciences Scholarship Workshop. In my assignment video, I will break down and answer the prompt, but also present a hands-on model of my explanation. Thank you, and let's begin. In order to give a more detailed explanation, let's start by breaking down the prompt. So we've heard this term before many times, but what exactly is science? The definition that I formulated was that science is a methodical and evidence-based practice of which humans identify certain problems, build testable models, and then develop answers in various forms surrounding the behavior of the physical and natural world. Now moving further along in the prompt, what is an answer-generating practice? There are many examples out there, but a few that I found were philosophy, culture, and religion. All of these examples generate answers through logic, faith, reasoning, and multiple more forms. Now tying these two together, what makes science a unique answer-generating practice? Its system by which it generates answers. The scientific method is the baseline model for solving any problem through science. Through observation, questioning, hypothesizing, experimenting, and formulating results, the scientific method is used to generate an answer. Ultimately, the scientific method is the most vital part of answer generation in the field of science. The scientific method is what separates science from all other answer-generating processes. Its application to all natural topics and repeatability through its defined format is what makes science what it is. Now here's a video of what answer generation looks like in the field of science. Hello, I want to start out by asking a question to set the stage for my experiment. What observable changes will occur when a combustible gas is placed in an enclosed space and then ignited? Since the vapor is in an enclosed system, I predict that there will be a large exothermic reaction that comes out of this valve. I'm going to start out by adding the alcohol into the bottle and then swishing it around to kill each side. Before I ignite the candle, I want to address safety, so I'm going to put my mask on, and I have a fire extinguisher just right here just in case. You see me switch to a lighter here because the candle wasn't giving me the results that I needed. So that experiment is known as the whoosh bottle experiment. I use a scientific method to create a question, form a hypothesis, run the test, make observations, and what I'm doing now, analyze. Now we saw the fire ignite because of remaining alcohol vapors remaining in the jug. Since they are flammable, a large flame bursts out of the top. Now going back to the scientific method, which is the process that makes its answer generation unique. It is repeatable, systematic, and testable. But this experiment also reveals the limitations behind the scientific method. The scientific method doesn't tell us what should happen, but it shows us what does happen under controlled conditions. It depends on the quality of our setup, our ability to measure accurately, and the assumptions we make. In the whoosh bottle experiment, for example, slight changes in fuel amount, oxygen inclusion, or timing can change the results, which reminds us that science is always open to revision. Now this is where ethics also plays a role. In this simple demonstration, proper practice was required. I handled flammable liquid safely, kept a fire extinguisher close, and properly disposed of all materials. Now this piece of information sets the stage for an even bigger picture. Just because something can be tested upon doesn't mean it should be, without regard for safety, integrity, and impact. As a concluding note, the scientific method is what makes science different from many other practices. It helps us to find certain answers, but ethics is what helps us apply those answers properly. Thank you, and I look forward to my future at Thomas Jefferson University.